All right, welcome to Wise Up on Air. How's everyone doing?
Good.
Hey,
All right. So exciting to be here today. We're going to go hands on getting started with spatial audio acoustics using Wise in Unreal. I'm joined here today by two of my colleagues at Audio Kinetic. Nate, let's start with you. Give us an introduction. What's your role at Audio Kinetic? And yeah, what do you get up to?
Yeah, my name's Nathan Harris. I'm the lead software developer of Spatial Audio. I work closely with Tally, and I've been at AK since 2012, a good while now, and we kind of kicked off the spatial audio project 6 years ago or so now. And it's really like evolved so much since then, and yeah, good to be here today, and it's going to be fun sharing some of our cool new features with you guys.
Awesome. Thanks for that. Handing it off to Tali.
yeah, my name is Tali Keklikian, and I'm working with Nate on the Spatial Audio team. What I especially do is port like all our features in Unreal and Unity, and today we're gonna see Unreal and play with it, so it's gonna be fun.
I can't wait. And I know there's some folks out there who are excited to take this beginner's approach to our spatial audio acoustics technology. So thanks for joining in with us today. If you're in the chat, give us a shout out. And as we're moving through the different features, let us know how it's landing. If you have questions, we'd love to be able to weave them into these demonstrations and be able to help surface things that we might not be covering. So yeah, give us a shout out in the chat anytime, and looking forward to engaging with folks during the next hour or so. But here we are doing this. And what is spatial audio? And we've said it before, and I'll say it again. It's really any technology that processes audio with the goal of convincing you that the sounds originate from the world around you. And in Wise, that comes across a couple of different categories within our pipeline and extending out into our integrations. The first one is the acoustic simulation side, which we're going to be focusing on today. The other piece is our 3D audio technologies, which we've talked a lot about in the past as part of our 3D audio object-based pipeline and delivering a binaural format. Not today, though. We are focused on these acoustic models and representations. And that encompasses a whole slew of features that include things like rooms and portals, portal spread, transmission and diffraction, early and late reflections, as well as our newly introduced reverb zones. So we're going to talk through each of those features from a hands-on perspective, from within the game engine, leveraging the tools that we provide, just from getting started with these cool things. So with that, we're going to jump into a live demo, handing it off to Tali.
Wow, already? Okay. Okay,
Waste no
everybody can.
time.
Wow. So everybody can see my map here. It's a forest with a couple of scenes or areas. We're using this map today, and it's like not available for everybody because it's like the best we found to showcase everything we wanted to show today. But you can try everything we're doing here in one of our samples, like Unreal and Unity. But today we're going to use Unreal. And this map has been created by Tom, which is our colleague in the spatial audio team, and a blog is going out with this map And everything we're going to talk about today, but more focused on Reverb Zones, it's going out next month. So you can read that if you don't want to listen to us. So let's start. I have a map. I have a little house here. I have like a clearing in the forest. Here I have like a little monster with sound. And I have another area here with a town, and I have like just like one sound for an NPC over there. But nothing else. So if I start the game, we're not gonna hear anything. So let's start with maybe we want to have an ambience for our forest outdoors area. So I'm gonna add a new spatial audio volume. And I'm gonna put it in the middle, and I'm going to put it super big. I don't know. That's too
Woo!
big.
Really long.
That's extremely big.
Sure.
Maybe not that big.
But it encompasses that entire outdoor area, and that's the goal, is to make sure
Right.
that you can define that outdoor space.
It's a little bit too low.
Oh,
Yes. Let's put it a little bit bigger
1
here.
centimeter high.
Great.
Okay.
Looking good.
So this area is a room, is also has the, let me just make sure that it's like, oh, I can't really know if it's touching the ground, is it? Let's put it in another perspective. We don't really need this to have walls or anything, but I wanted to at least have like a floor.
Have the floor.
Yeah. So I'm gonna put it, I don't know, right? Can I see something?
There we go.
So my floor is here. So it's super big. That doesn't need to be that big, but yeah.
But for me, I just love watching you navigate the tool set in Unreal to make sure that as you're authoring that outdoor spatial audio volume that you have it aligned correctly. I don't think I haven't messed with that perspective view very much, so it's nice to see you reach for that.
So which of the 3 components are we going to use on this spatial audio volume?
So because I want a floor, I think I'm going to leave a nibble surface reflector. We're not going to use reflect in this demo, but if we wanted to, then it would reflect on the ground, right?
So surface reflector is a bit of a weird name, but it just means like it will actually send the geometry to Wwise of the walls.
Exactly. In the surface reflector properties, we have diffraction. But well, for here, it's not really useful. We can remove that. And we have like the textures of, if, for example, we wanted to have a different texture for our ground here, we could put it here. But for now, we're going to leave it because that's really reflect oriented or auto reverb assignment. But I'm not sure we want reverb for our outdoors, so I'm going to remove reverb. So reverb, actually, we could remove the late reverb component completely if you don't want any reverb on here. And it needs to be a room, in my opinion, because I want to put a room tone. So in my ambient sound. And before this demo, I decided to create some ambient sounds in Wwise, so it's already ready.
And when you say room tone, what do you mean?
So it's an event that this room is playing. So the room becomes like a game object. But because it is a 3D shaped object, the sound comes from everywhere in that room. So whatever we are in this map, we're going to hear this ambience. So I called it play outdoors, auto post when I start playing, and I want it to send to other reverbs. For example, if I add them somewhere. So I'm going to put this to max, but you can put like your preferred number.
I think it's maybe also worth pointing out that like room tones in Wwise work a little bit differently than they might in other game engines, where you kind of enter a volume and then it plays, and then you exit the volume and it stops playing. In Wwise and in our Unreal integration, the room tone can be sort of thought as always playing, and then when you're inside it, it's like spatialized in surround sound, which means that if you had like an ambisonics or like a quad like sound field, then it would play like within the space, like fixed to the environment. So as you rotate, it would stay fixed. And then when you're outside the room, then it's spatialized as if it's coming from the closest point on the volume, and it will attenuate according to the distance from the volume. So it's really like a volumetric source in a sense.
And that's a great illustration that we're going to look at as we continue to author this world. For this outdoor space, we're always going to be in it. It's always going to be fully spread across all of the channels. And then we'll, as we get into authoring rooms and portals with inside of this outdoor space, we'll hear some of that phenomenon you're talking about.
Also, there's another thing we want to set is room transmission loss, that I think it should be 0. And that's so there's 2 transmission loss properties. There's one here in the surface properties. So each surface has a transmission value, like loss value. The sound will go through the surfaces around and then get attenuated, or whatever your curve for transmission looks like. This makes sense, like you want your sound to attenuate through the ground, so okay. But for the room, it means like the air inside attenuates your sound, but for outdoors it's fine.
So the surface transmission loss is really it's used by the like geometric engine. So when like a ray is fired and it intersects the triangle with that transmission loss, then it's going to apply that between, you know, an emitter and listener. And then the room transmission loss is kind of, because you don't always want geometry, and you don't want to necessarily have to perform complex geometrical calculations, we also have kind of a characteristic transmission loss of the entire room. And normally you can kind of put that to a value that is maybe kind of an average of all the surfaces. And it's mostly applicable to room tones, really.
Cool. Question coming in from the chat, and I'll try to frame it a little bit, right? So right now we're in this level, we're authoring a outdoor spatial audio volume, and a question coming in, could that spatial audio volume for the outdoor space be put into a blueprint? So if you have multiple levels, you don't need to place it in every level. One of the suggestions is the character blueprint. What's your suggestion there?
Yes, you could put it in a blueprint. You can also not create it at all, because we do have like a default outdoors room that is created, and then by C++ you could like send some information on that. For example, these things that we just did here. But if you wanted to change the properties, and it's easier for you to do it in the editor, then yes, you can do it in the scene or in a blueprint. The character blueprint, though, I'm not sure. The character moves, so I wouldn't want my room to move with my character, because every time it moves, we do like call spatial audio each time. Like we do send just like a new a new position.
And you certainly wouldn't want the room to rotate with the character. That would defeat the purpose.
Yeah. So maybe another blueprint could like it would be something like a basic ambient something. Then you just put it in and you put it in the middle, and it's super big, so it works for everything. But yeah.
Nice. Okay. Thanks for the question. Great answer. And let's go. I want to hear
Okay,
this.
so let's hear this ambience. Can you hear
Yeah.
So relaxing.
the little birds? I'm going to put it side by side with Wise and connect. And I'm just going to remove this weird editor Unreal input thingy. Okay.
And what's the configuration of the sound you're playing here? Like, is it multi-channel?
So my sound is, it's I took the sound from Strata, by the way, if you are familiar in the ambience. It's called Forest Coniferous Day Loop #1, I think. It's stereo, I think, so not too intense. But yeah, you can put whatever you want. And I decided to put these things. Wait, let me show you the other view for 2 seconds. Decided to put these under ambiences so that they all like kind of have the same attenuation. And I put like a big attenuation for all of them. This is in centimeters, so it's like 20 meters. But for the outdoors, I have another one. I put it a little bit smaller because we'll see. It's smaller because we're gonna go inside this house and I wanted to like attenuate, right? But yeah. And yeah, if we check the game object 3D viewer, we can see there's a big box around everything. And if I just enable the names here, I can see that I am inside a room and it's called Spatial Audio Volume. We could change the name, forgot to do that, but yes. Yeah. So next step is we're going to go inside this house, but nothing's gonna happen because we didn't do anything, right? So we're still hearing the little birds. Inside this house. Oops, I don't have no collision on my house. So yeah, how would we do so that when we go inside the house, we don't hear outside, right? So that's what we're gonna do right now. I'm just gonna change this and call it outdoors. And then we're gonna see the name in the game object viewer next time. Oh, I'm so far away now. Where is my cabin? Okay.
Cool.
Back to the cabin. Okay, so we want this cabin to be like a different environment. So we're going to put another room in there. So again, I'm gonna put a spatial audio volume. I'm gonna put it in the room, and I'm gonna use fit geometry. I think it's really far down there somewhere. Yes. Okay.
And
Kinda
just by
looks good.
toggling
Beautiful.
that switch, it immediately expanded to fill the space of that hut.
We can see like there are some points here that detected that there were walls, and that's how
Beautiful.
it was able to have the right size. So I'm going to remove this because this calculates the fit geometry each time I move. So I'm going to remove it, and I am going to check my parameters. So we want the geometry to be sent, so that's good. We might want a reverb, so I'm going to leave it this time, and it's a room, so that's good. We're leaving all these in. We want maybe diffraction, so maybe on the sides here, diffraction would be cool, so I'm going to leave it on.
What's diffraction again? I know we talked about transmission, but diffraction,
So diffraction is when the sound bends around obstacles. So if, for example, this thing was a sound and I'm behind the house, so it would bend around and then I would hear it. But then it would have some filtering going on, and depends on your diffraction curve.
Great.
When you allow diffraction, it's going to find every edge on your spatial audio volume and apply a diffraction edge over there. Okay, and then we could put some acoustic textures, but for now we don't need anything. The transmission is 100%. That makes sense because those are walls. And a late reverb, we could put something. We have like something that auto assigns aux buses. If not, then you just choose your own. Maybe it's a small room. Let's put a small room reverb. I have this already in my Wwise project. And aha, priority. So my outdoors has a priority of, where am I? 0. So because this room is inside, and I want to make sure that when my listener is in this room, it is assigned to that room instead of outdoors, I'm going to put a higher priority for my room. So let's put 1. And transmission loss, Nate, what's your opinion about that?
I think 1 is great. Like those are going to be pretty solid walls. Let's just say they block all the sound. Maybe if it was like a straw hut or something, you might want it less than 1, but
Great.
We could put an ambience here for the inside of our house, but for now, let's put nothing and just hear silence. We're in the house. It's a good and blocking sound house. The only thing left is a portal. Is there any questions? I see things in the chat.
There is a question about whether it's possible to create a replicable blueprint for the house and add the AkSpatialAudioVolume as a component to have the
Yes.
same occlusion whenever we place the house in the world.
Yes, exactly. It's just a little bit different because the spatial audio volume is our actor with all our components on. So our spatial audio volume has a surface reflector set component, a late reverb, and a room component. These late reverb and room components can be put on a collision or meshes. So if you had a blueprint with the mesh of this house, you could put a room under it. For surface reflector set, you can use our other component, which is similar but works with meshes. It's called AK geometry. So you could do that.
Great. And I see the other question in here about the best format for creating room tones. Let's circle back to that after we've successfully got this room and portal up and going. Thanks for the questions.
Yeah, so I'm gonna add a portal here because if I don't, and I don't know if we want to showcase this, but it's just gonna cut everything. There's gonna be no cut around here. We have a door, so we want to have some opening, and to create an opening inside a room, we need a portal. So we need a, let's go all classes, AK acoustic portal. This is our actor for portals. It's on the right, no, it's the wrong side. I'm just going to rotate it. And there is, inside this actor, there is a component. So you can put this in a blueprint before you ask me. So we're going to rotate.
And a portal
so you might have like a door blueprint or something that would have a portal attached to it.
Got it. Got it. And basically portal connecting 2 rooms. That's what he does.
So right now we can see that it's connecting outdoors with the spatial audio volume inside that I didn't change. I'm gonna write it. I'm gonna wood cabin.
Nice.
So my portal is connecting outdoors and wood cabin. Now it's too big, so there's a fit to geometry here. 2.
You guys might have noticed that it changed from red to blue. That's because it detected that it's actually connecting 2 different rooms. If it's red, then it means it's not placed correctly. It's like kind of, yeah, the front and back are in the same room.
Nice.
So it fit the geometry. I can fit to my doorway here, and I'm just going to put it a little bit less big here as the depth. It's like a area where you transition from one room to the other. It transitions reverbs.
Yeah, it's not a crossfade,
Crossfading.
but it's a dynamic volume scaling as you move through that portal.
It does crossfade the send to reverb, but we have no reverb outside, but it's going to start sending to the reverb inside while you're crossing if there is a sound crossing this portal.
Got it.
So I'm just gonna.
It's fully dynamic though. It's not like you cross a trigger line and it fades one out and fades the other one in.
Right.
This is like fully real time as you're moving through, you're controlling the crossfade between the two rooms.
Yeah, one of our sort of philosophies is like we want everything to be based on space and not time. So there's nothing in Wise Spatial Audio that fades over time right now. Everything is based on a position in the world.
Yeah, would you say that it interpolates values between those two spaces?
Yeah, there's a number of things that are interpolated as you cross a portal. For example, like the spread of the sounds on each side is collapsed as you transition through the portal. And that's probably, it's one of the main things that portals do, I guess. But yeah, if you're finding that the transition between rooms is a little abrupt, then try making the portal longer. And that should smooth things out.
Nice. Great example. Thanks for the question in there. And there's a comment here. Does the ambient sound emitter follow the character inside of the volume? And I think we're about to hear what happens.
Let's try it.
Yes. I'm going to put this side by side for the moment. I'm still connected. Oh, everybody disappeared. I don't know if I'm alone.
I still hear you. You're still streaming. We'll have you back in a second. It seems like we're working through this. It's working good. And we're back. Great.
And is Nate still here?
I'm here.
Still
okay.
Here.
You just don't have a camera.
You don't have a camera.
I don't.
Oh, you're back.
The birds.
Okay, I'm back.
Meanwhile, the birds are still singing.
So I'm going to zoom in here. Can everybody still see my screen?
Yes.
Yeah.
I have a feeling that whenever you go enter play mode, it has a quick think about it and takes a second to recover.
Okay. So I'm outside. I can hear the outdoor sound around everything, and this small. Let me just center my camera on this. Okay, this small. Well, this represents like coming from everywhere except from this small circle here. Because I'm just in front of a portal, and the ambience doesn't come from the portal, but it comes from everywhere else. So that's what it means. That's my spread. And when I go inside, silence. We can see the spread change. Now I'm only hearing the ambience from the portal, and I'm hearing silence from my room. If I put another ambience, I would hear this other ambience.
It's the outdoor ambience is really quiet right now, and that's because of the attenuation curve that has been applied to it.
Exactly.
So
that's why
fairly like steep roll off.
That's why I decided to put a really small attenuation curve for the outdoors, just to like showcase this example here. but whoa.
So right now the outdoors is being rendered as coming from the portal, almost as if it's a point source. Has a little bit of spread. If the portal was wider, then you'd have a wider spread as well. Yeah, so it's basically like a smooth transition between a surround sound field and a point source sound emitter.
It's so evocative with the way that that cone illustrates the collapsing of that outdoor ambient as you move into the room. That makes a very clear proposition for that. So the sound is attached to that giant outdoor spatial audio volume, and as you go into the room, it attenuates that. So cool.
Are you guys hearing the ambience cutout as well? Is that a streaming issue?
I think it's a automatic muting of that ambient from some service somewhere.
Okay, well, on my side it doesn't cut, so believe me.
Okay.
So now there is this area here with a little enemy that makes sound.
So far what Tally's demonstrated is like has been available in Wwise for a number of years now, although it's has been improved in various ways. But I think what we're about to get into here is going to demonstrate the power of our new 23.1 features. Is that right, Tally?
Yeah, well, not right now, but what we're gonna do.
I won't jump the gun then.
But yes, because one thing you would want to do is in this clearing with the enemy, maybe we don't want to hear the little birds anymore, right? Because it's different. There's no like trees anymore and stuff, and maybe you want to like hear the sound of the enemy better or something. So
I mean, when you've got a spooky monster creeping around, like the birds are not they're not hanging for that.
No, they're not hanging. Yeah,
out of here, right?
Exactly. So what do? Like we could say we could add a box for a room, but then it would be weird. Like, where do we put our portals? Do we put it on the paths here? But what if I just decide to go through the forest? That's gonna be weird. It's gonna like diffract on my portal. So what should we do? We should add a reverb zone. Yay! Yeah! Okay, so let's add a reverb zone. I'm gonna put this back.
Reverb zones new in Wwise 2023.1, added to both the Unreal and Unity integrations, and we're about to demonstrate how that works, placing it into a map without attaching any portals, but getting a smooth transition between different areas. So yeah, this is going to be a great solution.
Yeah. So for reverb zones, we created an actor. For the next point release, I'm hoping to get a component for it, or maybe like being able to put it on blueprints, because everybody likes blueprints, it seems, in the chat. For now, it's an actor, and you can use blueprint functions to try to do the same thing. But okay, so for now, we're gonna add an actor volume, and it's called a reverb zone. We're gonna put it here. I'm gonna try.
That was a reverb volume.
Oops, no reverb volume. Thank you.
This is perhaps a point of confusion.
Yes.
A reverb volume is an old component that doesn't work with Wwise Spatial Audio.
If we check, actually, I'm gonna put it back and just show you the difference. The reverb volume is an actor with the late reverb component, and that's it. So you can use it just for reverbs, but it doesn't have room and geometry like the spatial audio volume. And the reverb zone actor has a spatial audio volume, the same components as a spatial audio volume, the geometry, the reverb, and the room. And the reverb zone is a room. It needs to be a room so that it works. So
the
not be this
reverb
one.
the reverb volume is going to superimpose an additional reverb send like on top of the outdoor environment, which is not what we want. We want to kind of carve out an area, and that's what the reverb zone is going to allow us to do.
So for our reverb zone, we have different, or let's call it clearing. We have different property values. So we don't enable the geometry because there's nothing, like there's no geometry, right? There's no walls or anything. Even the floor is not needed because you already have a floor for the big room. Exactly. So there's no geometry being sent as like reflective or diffraction, but there's still going to be like a shapes being set, like a size and something.
Right. So reverb zones inherently have geometry, but by disabling that checkbox, it means that the geometry won't be used for reflection and diffraction.
Yeah.
And it'll only be used to delineate the reverb zone.
We could have some reverb or not. It's called reverb zone, but it can also be used for like a different ambience. Right now, we're going to use it for a different ambience. We could also add a reverb. I'm going to leave it on, but I'm not going to add any reverb for it. The reverb zone needs a parent room. And in this case, it's going to be the outdoors room we have. So I'm going to set it here.
And remember that setting the parent is important because that's how it tells the spatial audio engine like how to propagate the sound in between the reverb zones and its parent.
It's like the portal before. Like the portal knew we were passing from wood cabin to outdoors, and now we know that we're passing from clearing to outdoors with this property. There's a transition region width, which is like the same thing as the length of our portal before. We're just gonna leave it to the default one for now. And okay, so I'm gonna try the fit to geometry if I can. You think it's gonna work?
Is that gonna work?
I don't know.
Yeah, sort of.
Something. I can always just change it a little bit.
Can give you a starting point.
Yeah. Oh. I think it's not so bad.
Not so bad. You might want it a bit taller.
Yeah.
You might need to turn off fit to geometry.
True. Okay. So something that needs to be done here is I'm also going to align it with the floor like I did before. And I'm going to say that there is a floor there.
Right.
Because right now, if I leave it like this, there's going to be like every wall is going to be like a portal, even the ceiling and the floor. The ceiling makes sense, but the floor would mean that like the outdoors ambience comes from the floor. We don't really want that, so we're going to remove that. So wait.
And I think it makes a really clear illustration when you look at those transition regions and how they're represented over in Wwise. Right? Because you can.
What?
So when you remove the floor, it won't have a transition region on the bottom. Right?
Right. And we'll see that in the 3D viewer when we connect Wwise.
Totally, totally.
Actually, it's adding the floor. I removed all the
the faces
and then just add the floor.
Cool.
They're
And I
enabled by default.
normally they are not supposed to, but I'm not sure why it was here. So we'll see next time we add a reverb zone. And if not, then it's a bug. Oops. So I added, actually, I'm gonna add the ceiling too.
Yeah. Okay.
I don't know. Do we want to hear the birds coming from up from
Well,
the
who's got
top?
their height channels?
People in the chat, I'm sure. I'm
Awesome.
just gonna put it anyway.
Sure.
Although it's only a stereo ambience, so
True.
if you had an ambisonics ambience with content coming from above, then putting a surface here would block it.
Right. Or if you've got game objects of birds flying around with
Right.
emitters on them, you know, monopositional, yeah, you'd get that height information.
Yeah, so with reverb zones, you always have to think about like where the sound should come from and where it shouldn't. And you can think of the disabled surfaces, which we call transparent surfaces, are kind of like your portals, and then the solid surfaces are kind of like your walls. And the ability to define what are basically portals by just using geometry is quite powerful, and you can really get creative with the shapes of your rooms as well.
Nice. And that is to say, one of the questions that has just come in is that these volumes, portals, reverb zones, they can all be manipulated with the modeling tools in the Unreal Engine, for instance, the extrude tool, all of the shaping.
Yeah.
Right now we're just using cubes, but it could be anything.
Great. Thanks for the question.
And when you click on this, it's not just to edit the surfaces, it's also you can change, you can select individual vertices, like it's the brush editing view.
Cool.
Okay, so reverb, we decided not to put anything. The priority 1, because we're inside. Outdoors, there's no
Outdoors is
transmission
0?
loss. Outdoors is 0.
Gotcha. So we need to have a higher priority.
Yeah, because if not, then we're gonna go inside and it's not gonna be like clear like which one we're in. Are we in outdoors or are we in our reverb zone? We're not gonna be sure because they have the same priority. Okay, so we want to have a different ambience or nothing, but I found something that is like a little bit like just windy. So I created it, and it's our clearing, play, clearing, photo post. Okay.
Awesome. So as we transition into this reverb zone from the forest, we're going to hear that room tone, that outdoor ambience with the birds chirping. It's going to attenuate, get quieter as we approach and go into the reverb zone. And what's going to come up is the new room tone that you're associating with the reverb zone, which is kind of a windy thing, much more sparse.
Yeah, that's right. So we can hear the little birds. We can see that my clearing is being played, my clearing sound, but it has a distance saturation on it, and we don't hear it right now because it's too far. But the more I
So
go
those slightly bizarre looking blue triangles indicate the transition regions. They look a bit like boxes, but they should really be kind of blobs around the triangles because they go in all directions. Looks a little bit narrow. I might
you would put it higher. We
widen them
change.
a bit, but let's try it just to see how it sounds.
Did you hear it, or did you hear my enemy sound that I could
I
mute?
definitely heard the monster.
I heard the transition too.
Yeah.
We can remove the monster while we demonstrate this.
And are we hearing the clearing sound when we're outside the region as well?
Wait, what? Huh? Are we hearing the outside? Yeah, wait. I'm gonna show this. I'm gonna just mute this first. Okay.
Cool.
Yeah.
Okay, so the little birds is outdoors, and while we're going in, we get distance attenuation.
So perhaps a common point of confusion is that the transition region is not going to define how far you hear your sound. That's always defined by the attenuation curve.
Yeah, we can still hear it supposedly here.
The transition region is just used for crossfading sends.
And the clearing, now that I'm inside the clearing, I can see that we have no distance attenuation, but if I was outside, then the distance attenuation starts. But normally I'm still hearing, because I have a really long attenuation for my clearing sound. I am hearing the clearing at the same time as outdoors right now. Yeah. We can all change that the way we want. So yes.
Cool. And a question coming from the chat.
Yeah.
Why so many triangles on the reverb zone representation inside the Wwise Game Object 3D viewer?
Right. Maybe try toggling the just toggle the show transition region. That might make it a little bit more clear. Yeah, it's the transition
region.
Yeah, so that's like what it, those are the actual, those are the solid surfaces. We also have the ability to show the transparent surfaces in the debug options there. That's all the geometry that makes up the reverb zone. And then we can toggle on the transition region, which are drawn as like boxes around the triangles. Yeah. Eventually, I'd like to have a better way of rendering those transition regions, but in a pinch, that's what we came up with.
Yeah, so it's just a visual representation in Wwise. It doesn't affect calculations in the editor, is a follow-up question there.
Well, it does affect calculations, but it doesn't block sound in any way.
Cool.
It's doing the same thing as a portal,
right.
Transitioning the reverbs, sending to one reverb to the other reverb. But in this scenario, we have no reverb, so actually we should not even look at it.
It's not really doing much.
And I wanted to show the spread.
Yeah.
Look at it. It's more on the top because we have it really high, but it yeah. It would have been different if it wasn't that high.
So what we're actually looking at a different spread algorithm than what is currently in 23.1.0. It's what I call a volumetric spread, and it adjusts dynamically to the shape of the region. So if you say you even had like a U-shaped region and you were in the middle of the U, you'd still hear the sound coming from all around you. So I think it sounds pretty good, and I'm excited to get some feedback from you guys when you hear it, hopefully in 23.1.1.
Awesome. Wow. Foreshadowing spoilers for 23.1.1.
Yeah, we're actually using a 23.1.1 build from...
We're from the future.
From yesterday or something. Yeah.
Totally. And that's one thing about spatial audio is that it is a in progress set of features, always moving forward. The team is constantly shifting between, going hard on the science and representation of realism towards this kind of acoustic simulation, as well as optimizing on performance and bringing usability and creative control to these different tools. So I love the continued improvement that happens over releases, and this is just another example of that. So nice work.
Okay.
Yeah.
Next step is this enemy that we muted. I wanted to maybe like a little example of if we're behind this tree, maybe we should have some diffraction going on. Right now, nothing changes.
And diffraction, remind me again.
But you're gonna see it. It's gonna bend around the tree. Let's do something about it.
Cool.
Okay, so this tree is round, but we won't we won't really hear the difference if we put a round geometry or a square geometry. So we're just gonna put a square geometry. The easiest way is like using the same actors, the AkSpatialAudioVolume that we used since the beginning. And maybe
Yeah,
just
always
having
keep in mind that diffraction calculations can be CPU intensive, so we want to always use as few triangles as possible. So that's why Tally's elected to use just a box shape here.
Yeah, I'm gonna put it inside the trunk. So let's just move it a little bit smaller like this. And smaller. Smaller.
That's not
Anyway.
going to block a lot of sound.
Yeah, it's gonna block some sound. Okay, let's say it's like this. The only thing is I don't want any diffraction coming from the top, so I'm gonna remove this geometry on top.
Yes.
So you're
Again,
enabling...
always optimizing to remove triangles where they're not needed and remove edges when they're not needed by disabling the boundary edges.
So I have geometry on the 4 sides and I've put it inside. Maybe I'm gonna put it more obviously inside, so I know that there's not going to be any diffraction paths going under because we have the whole floor as a geometry, and we're not going to have any edges around here. We can see there are a different color. The edges are going to be on the hard blue lines here,
and we'll see that clearly in the 3D viewer as well.
Yeah. Yeah. Okay. Let's try. Can we see a difference? Let's see how it looks like in. So there are some diffraction going on. I'm just going to reposition on my camera. Oh. So we can see there are some diffraction going on, but maybe it's not enough. We want more diffraction, so we can. Am I still here? People disappeared from.
You're still here.
Perfect. So we can. I'm gonna select my enemy random container. And in my positioning, I have an attenuation. And the attenuation, there is some diffraction and transmission curves. So maybe I can put something different.
So customizing the diffraction curves for a particular sound here.
Maybe we want something more intense like this. Or maybe this one's not enough.
Do we have enabled diffraction and transmission on the sound? Just the, yeah.
Perfect. Another key piece of the spatial audio pipeline in Wwise is making sure that a sound that you expect to diffract or have transmission applied has that toggle in the positioning tab enabled.
So I stopped time here in my profiling just to get one of the sounds in. So this sound, one of the random sounds that is being played, has -9 and 26 filtering here in LPF. That's because there is diffraction going on. Transmission. My transmission is not so hard, so I'm gonna like do something about it.
Oh yeah, that's right. We're getting the transmission path coming through the
trunk, yeah.
yeah.
So my transmission, I'm gonna put some custom curves. So maybe.
And usually you want it to be completely silent at the end of the curve for both diffraction and transmission.
Really? Okay.
Because we kind of assume that if it's either 100% transmission loss or 100% diffraction, that it's not going to be audible. And we make a few optimizations inside the spatial audio under that assumption. So if you want to avoid anything sort of cutting out, then that's kind of the best practice there.
I'm not sure where I changed my diffraction before, but it looks like it didn't work. So I'm gonna do it again.
Oh, weird.
Transmission. Oh, the diffraction you wanted it to be okay. Maybe not that much then.
Yeah.
Let's do something like this.
I'm surprised we're still hearing it so audibly.
Let's see.
Is it updating?
It's supposed to. Well, I can see that like the sound
yeah,
is
it's
more intense. Maybe
I'm
like the volume
it.
is not is just -10. So maybe we
but
could put
low pass
something...
filter of 30 should be pretty audible. Can you try just moving the camera position and see what the difference is?
And you'll need to
there we go.
Over there, yeah.
Oh, you just had to click on the game for it to
update.
Yeah.
Nice.
All right, now it's bright and clear, and then
I don't hear it that much. But...
I don't hear it either. I don't know what's happening.
But the volume is pretty high. The LPF is just 18. Why? I guess we have like a diffraction that is just like this.
Yeah, maybe you could try making the tree wider.
Yeah.
That's just going to make it more obvious because you're not going to get an extreme diffraction angle around a thin post like that.
Well, and that's part of, this idea of representing reality versus, having a creative solution or applying creativity to make it sound the way that you expect it to under a circumstance.
Yeah.
So.
And see, now it's like almost too diffracted.
Yeah.
But yeah.
Experimenting.
Lots to experiment with here. It sounds like it's miles away. But you guys get the idea.
So yeah, anyway, we're back in our outdoors ambience over here. And we have another clearing here in a town. So we're gonna do something else about this part. I don't see your faces anymore, so that's super sad.
Every time we go in and out of play mode, there's a little bit of wiggling that happens behind the scene with all of these services running to support the live stream. So bear with us out there in live stream land, and thanks behind the scenes for everyone's patience.
So I want to add another reverb zone over here. Maybe this.
This is for a whole tiny town of cabins that you've carved out in the forest.
Ooh, look at this.
I
How
love that you're
beautiful.
getting the fit to geometry to work for you
Yeah.
so well here. That's great.
Oh no.
You need to toggle it
remove
off. Yeah.
Okay. I'm going to remove it. I'm gonna place it again. We're gonna do the same thing.
Got to have our floor.
Well, that's not it. Well, that's it. That's the one. Oh, I'm pretty not too bad here. Oh
Yeah,
wait.
pretty good.
No, it's this one. Nope. Okay. Okay.
Cool. Well, while we're working on that, a question came in asking if you're using an AK reverb zone with a room component in it, is the only difference the surface reflector? Or are there differences?
With the spatial audio volume? Yeah, the difference with actually the reverb zone actor is inherits from the spatial audio volume actor. It's like the same thing, but there's just like a couple of properties that are modified. So the surface reflector is disabled, and well, there are a parent and a transition region property, of course. And there is, so that's nowhere else you can see right now.
Got it.
I'd like to add them to the room component so that the reverb zone can become a component, but that's in the future. And
so a reverb zone is a room. Like it's has all the features of a room. It just has like an additional property, which is the parent room and the transition region width. And from an API perspective, you have to create a room first, and then you call set reverb zone to assign that room as a reverb zone, which basically assigns the parent and the transition region width.
Got it. Cool. Great question. Thanks in the chat, and keep them coming. We're happy to be moving along with the fundamental steps towards setting up this small map with spatial audio acoustic features in Wwise. It's coming along great.
so I have another ambience for that one. I added it. I removed all the surfaces so they're all transparent, except for, I'm gonna do the same thing. I'm gonna add the floor and the ceiling. Yeah, and for the town, I think the town needs to have it because the ambience I chose for this is like some birds, but like further away birds and some wind. But in the town, we want like a town ambience with people talking and stuff. So
Yeah.
let's put another reverb zone over there. This one, I don't think I'll be able to use fit the geometry.
But I want to know which one of these huts is the karaoke hut in town.
It's the bar.
Perfect.
It's the
walrus room.
Walrus room.
Nice. Oh, fantastic.
Bit of an inside joke.
It's great.
Okay, so I'm trying to like have it.
So what Telly's doing here is creating a reverb zone inside a reverb zone. They can be arbitrarily nested.
Great. So one reverb zone is in this entire clearing, And then this second reverb zone that you're nesting there is around the town itself.
Yes. Right, I think around here it's cool. Just gonna put a little bit of height there. And align it again. 4. Okay. I'm going to put the same things as before. No reverb for now. I play town that I've prepared.
Nice.
Some geometry on top and on the bottom. Well, enabled triangles.
Seeing a question, what are the best practices, use cases for using rooms versus reverb zones?
Yeah.
I mean, if you can get away with using just plain rooms and portals, then you probably should. They're a little bit simpler, like computationally. But usually your game, like your game level, is going to sort of dictate which one makes the most sense. Are there more walls or are there more open spaces? If there are more walls that can, you know, and you can easily delineate your rooms with portals, then use rooms and portals. But if you're trying to design these sort of wide open spaces where you've got more negative space and more positive space, then that's really what reverb zones are for. Does that make sense?
Great answer. Thanks for grabbing that one from the chat, and thanks for your question today. Yeah.
For the town reverb zone, I just wanted to say that since it's inside the meadow, the parent is going to be the meadow. Oh, I didn't give them names. Let's do that before. So the parent here is the meadow.
So I
And
noticed that you have the ceiling on the town ambience.
yeah, maybe not.
I think though, okay, so it depends, right? Like because if you disable the ceiling, then depending on how high it is, you might get sound like coming in from the top. Because the ambience layer of the parent reverb zone is going to be positioned at the closest point, like on the outer perimeter, to the listener at any given point in time. So if your ceiling's not high enough, then you might just have the ambient sort of follow you around above, which might not be what you want. So
but here it does
but here
sense.
it's probably high enough, and
it does make sense to get the metal ambience from the top, because I already have a different ambience for the metal.
Right.
So I think this one makes sense to have only the.
Yeah, with the reverb zones, you always have to be careful which surfaces are enabled and which surfaces are disabled. It's kind of a recurring theme here.
Also, the priority of our meadow is 1, like every other room that we've done until now. But now we're going 1 level deeper. So our town is going to be priority 2, because it's higher priority than the meadow and even less than the outdoors. Even more than the outdoors. Yeah, and then I was quickly adding a room inside this house here, just for fun.
It's like reverb zone rooms and portals inceptions. You have to figure out which level you're on and where you're going and how those priorities work together to get you to the right level of detail.
We're on priority 4 now, aren't we?
4? Are we? No, or 3.
We're 3? Oh,
This
because we have 0.
because we 0.
Yeah, yeah.
This one's
Off by 1
very.
error.
But we can put 4 too. But this one's if I remember, I put this one. I put 2. So this one has 3, and I need to put a portal. Rotate it. Fit it inside. Maybe
Nice.
have a little bit less. Whoops, not this one. A little bit less here. So the town and, well, spatial audio volume 2, that's the townhouse. Something. What's okay, a pearl, what's this one?
Tree trunk.
3.
Tree trunk. Yeah. Oops. Okay. Just want to move in here. Okay. So let's try this now, and we'll do the bar later. Let's let's go. I'm gonna start around here.
Okay, and we still have that issue where when Nate or I speaks, it ducks the sound of Unreal.
Okay.
When you're auditioning. So Nate and I will be mindful of that.
Okay. So can you hear the ambience?
Yeah.
The wind sound is a little bit different and doesn't blend well, but anyway. This is my 2 different, and also the town.
Hello!
Oh, this is my quest giver guy. We're gonna go back to this one later. So yeah, maybe we can try to go inside this house here. Okay.
Cool.
Sounds pretty okay.
And again, sounds collapsing through that portal into the townhouse, positionally, you know, coming from the direction of that portal. And then as you exit that house, you know, expanding back to the multi-channel representation and unfolding in its beauty of ambient sound. Nice.
Cool.
So yeah, we could add like portals and rooms on every one of these houses, but let's concentrate on this bar here.
Hello!
With my little guy that's saying wants to speak with me.
Hello!
So what do we want to do with this? Open Unreal again. So we can, as normally, we can add a room inside the bar, have a door here. But what about this area? Can we put a room there? When we don't have like a clear area, like we have a clear area here for the door, and a portal can be put here, but no other portal from this area to here. We can leave it like that and have it just with nothing, but maybe we want to have a different reverb here, or maybe there is a little speaker with the sound with a little ambience inside this terrace.
Yeah, it's true. We've been mostly focusing on ambient sounds in this demo, and I guess they are, you know, they're a little bit more obvious and like easier to demonstrate. But everything that we've done for like ambience design in this whole little tutorial here. It can also be applied to reverb design. So each one of these reverb zones can, well, they are called reverb zones after all. They can have their own unique reverbs. And this little covered patio here is probably a great candidate for a unique reverb. So,
and we really mean auxiliary send when we're getting specific here, because the key piece that connects a reverb zone in Unreal to Wwise is the association to the auxiliary send.
Yeah, let's we can continue this conversation. In the meantime, I'm just gonna add a room like normal inside the bar.
Sounds great. And there was a question that came in a little while ago, and as we've continued to add complexity, I've held off from asking it. But the question was, any tips for managing complex landscapes with spatial audio? And, this could be a moment where, as we've continually added to this world with layers, rooms, portals, reverb zones, how does this scale in complexity?
yeah, I think it's a great question. I think one thing that, has again already come up quite a bit is using blueprints, right? So like whenever if you have like a door actor blueprint, then you automatically have a portal attached to that actor, and that is going to save you a lot of time of like placing portals. And any reusable blueprint component, think about like building your spatial audio acoustics design like right into the blueprint. Any other thoughts, Tally, about that? She's preoccupied.
I am. I'm wondering why the geometry doesn't work.
It's worked so well for you so far.
I think maybe it wasn't like rotated correctly.
There you go.
Could also be the collision layers. Right. The fit to geometry works by casting rays like inside the editor world, and you have to have a collision on the geometry that you're trying to fit to. And that's why you can customize the collision layers that it casts against when you're placing the volumes.
Well, doesn't work.
You win some, you lose some.
Mm-hmm. It's all just rays after all. Nice. So if there's any folks out there who have leveraged spatial audio already in part of their experiences, feel free to chime in with any suggestions for scaling complexity. Again, we're always trying to find the right intersection between the tools we provide and the worlds that you're out there creating. And so keep us posted on how you're using the tool over time and what you come up with. Question coming in: Will there be an update to fit to geometry for complex shapes?
Yeah, I think it's about due for an update, isn't it? It's something that we did. I don't know, was it like 3 years ago now? And
yeah, there was a great Wwise Worldwide Online Expo where we unpacked the feature in its infancy, and yeah, again, great opportunity to revisit.
And the truth is that it works quite well when you have these sort of box shapes, but then most of the most of the words people create are don't fit nicely into boxes, unfortunately. So I think there's definitely room for improvement there.
And the fit to geometry feature does have a couple of different modes to its raycasting, doesn't it?
Yeah. So it has like an axis aligned box mode, and then it has a rotated box where it will try to find the correct orientation as well, and then a convex shape mode. And as you get more complex, it kind of is, to be honest, less likely to work. It's a difficult problem, and it will require a bit of research on our end to improve it. But it's something I'm interested in tackling in the future for sure.
Cool. Continuous improvement.
I mean, I think
always.
the holy grail is to just you know, have everything be populated automatically in your level. Like, no one really enjoys like fitting these little boxes. That's something like we're well aware of, and we'll be looking for solutions to that.
Nice. Well, as we're talking, Tali is just working away, populating this map.
It's nuts. It's snapping weird.
Yeah, I'm sure I could change the snapping, but I don't want to right now.
Tiny victories where you can
Okay,
get them.
it's not perfect.
That's looking pretty
but
good.
It's okay.
Yeah.
I'm going to have some surfaces that are not invisible. The floor, the ceiling, because there's something on top, and
Yeah.
this one because it's the bar.
Yeah. Usually when you have a portal connecting your reverb zone, you want the surface that the portal interfaces with to be opaque, like Tally did just right now.
This Reverb Zones parent is a town. And we can see here we're
Nice.
It's not supposed to be town. Why? Because priorities.
Right.
Nice.
Priority. So we're at what, 4 now? Are we? I'm not 3.
3, I think.
3. So
Level 3 reverb
zone.
zone.
And okay, that thing is a bar. Okay. Reverb zone. Okay, so this is like the patio area.
Nice.
Patio bar, perfect. And
cool. What are we gonna do with this reverb zone?
Let's put some reverb. Let's put the small room reverb, and the bar has a large room reverb. Well, we won't be able to hear really, but we'll be able to see the voice graphs. Where does the sound pass and where does it get sent?
Someone in the chat just got the pun in the name of the title.
Woo.
And another question coming in: are the settings of the volumes able to be updated at runtime?
Yes, most of them, yes. If not, then it means that it was forgotten or we didn't have time to do it. But most of the time, I want every property to be able to be changed at runtime. In 24, I'm gonna like review everything, make sure like
yep, keep us
make
posted.
sure it's perfect.
Keep us posted out there. And then is there a recommendation for making a reverb zone manager? Like, is that something that that you're imagining people would want to expand?
Manager, like what?
Yeah, what does that mean exactly?
Yeah, good question. Fill us in the chat. Keep the questions coming. They definitely make this a more educational experience for both of us. So Reverb Zone Manager, let us know. And does that bar have a room tone associated with it?
Yes, the bar has a bar ambience,
Cool.
so that's
Sweet.
gonna be cool. I put it here. Play restaurant. I think that's it. I don't think I remember. I forgot anything. Let me check. Priority bar. Blah blah blah. Okay, let's try it.
Hello.
Oh my god. Okay. Okay, let's just put this on the
Hello.
side. Okay, let's look at it here.
Cool.
Hello.
That's how it looks like. And if I just go back and
Hello.
let's take this one here, he's yelling here.
Hello.
Okay. Can we pause? Let's pause and open this. Mhm.
Cool.
Okay, so in this scenario here, we've got our yelling being emitted inside the patio. And we can see that it's being sent to the patio and then back to our listener. But at the same time, since it's just close to a room door to another room, it's also sending to this other room, the bar, then back
Perfect.
to our ears, and also directly into our ears, like this. So that's the first scenario we can see. Now let's see when I go inside the bar. I'm not live.
Hello.
So I have my little restaurant ambience here.
Very cool.
Okay, let's pause to the yelling. Where is it?
Hello.
Here, let's pause. So now we're inside. We get a diffraction on the portal. We get transmission through the wall. Again, the sound is being sent to the two reverbs. And also because I am inside another room, I'm getting some reverb being sent to another reverb.
Cool.
So maybe this is a good time to talk about something we changed in 23.1. Before in 22.1 and previous, an emitter would only excite the room that it's directly in, which in this case, because the quest giver is in the patio, it would only send to the patio. And for 23.1, we've added a new connection where the quest giver can actually excite adjacent rooms as well. It's going to be probably a smallish contribution because it takes into account the fact that it has to go through a portal. But it's especially useful if you have, you know, large portals like your think of the example I like to give is if you're sort of shouting at the mouth of a cave, then but you're not actually in the cave, then in real life you expect the sound to propagate into the cave and then be reflected back out. And that's something that we now take into account in our sound propagation system. So
Nice.
pretty cool stuff.
And is that also a piece of that is that revised aux-send
Yeah, so
model.
that's what we're calling the revised aux-send model. I actually wrote a rather extensive blog about it that was published I think last week. So
we'll get a
if you
link
want to learn
to that
more,
blog
check that
in
out.
there.
Yeah.
Yep. Link to the blog in the chat here in a sec. And yeah, I mean, again, just increasing the opportunities to exact precision as sound propagates through the world like you just described. Huge step forward. Someone is back with explanation of Reverb Zone Manager, meaning exposing multiple Reverb Zone settings to a single blueprint.
Yeah, the API is just called, like, the API function is just called set reverb zone, and then you pass a room and a parent. So you could like have a blueprint that calls that function. It's also a blueprint for a lot of rooms and parents in your
Yeah, presumably that's something one could set up through a blueprint to kind of quickly adjust the settings of all their reverb zones.
Cool.
yeah. In Unity also it makes sense because the way I implemented it is a component just called reverb zone where you pass the room and the parent and the transition region. I just didn't mention it, but yeah. And then this component could be added on a game object with like lots of other reverb zone components with different rooms and parents. If there are Unity users in somewhere over here.
Yeah. Cool. Thanks. Thanks for the question and clarification. And I feel like we've got a very clear scenario illustrating all of these different tools that are provided as part of the spatial audio acoustics integration and tool set. Really cool to see something come together in front of our eyes. That's been super fun to follow along and see. Anything else in the box, or are we closing out?
Yeah. I'm wondering like if people want, like, the only thing you mentioned, Damien, maybe we could look at init settings, but maybe
Ooh.
not.
Well, why not? We're here. It just makes me think that that could be fun.
Init settings. Yeah, we have
Just-
new
right.
init settings. Well, for the new accent model that we just talked about, we have max emitter room accent that is new. So you can limit the number of rooms your sound is going to send apart from the room he's already in. It's already in. So yeah, here it's 3 as a default, but you can put something else.
And I guess the idea of limiting this is because we kind of imagined a scenario where, you know, you're outside and you had a bunch of little buildings and they all had different, you know, they were all different rooms, and then maybe there's even like hundreds of them, and we didn't want to completely overwhelm the voice graph. So why not limit it to the, you know, 3 closest rooms? There's no point in trying to sort of excite a room that's on the other side of the map. Like, you're not going to hear that. And realistically, I think 3 is a good starting point. If you set it to 1, you're going to get the behavior. You're going to get something like similar to the behavior of 22.1, where you just get a direct crossfade when the emitter is transitioning to another room, but you won't get the like exciting of adjacent rooms. Less exciting.
Definitely. And that's based on priority. So it's the priority of those closest rooms, or in order of priority.
Yeah, it's going to, I mean, specifically it's based on the angle to the portals for those rooms. So if you have a room that's slightly farther away, but it has a really big portal, then you might choose that one over a closer one with a smaller portal.
Cool. Thanks for the precision on that.
do we want to go over the rest of the settings just because this
Well,
is
maybe the other one that is important is the first three, because those changed since continuous recasting for 23.
Great.
right? So um now number of primary rays, we recommend setting a lower value than we had before, because every frame we cast rays no matter what. Previously we would cast rays only when the listener moved past the movement threshold above, but we realized that there is not really a downside to casting rays on each frame, and it allows us to use a lower number of primary rays and spread that load across all the frames. So you're going to get a much lower peak CPU usage if you in 23.1 with continuous ray casting. We're going to have a detailed blog article about that coming sometime in the new year, written by my colleague Christoph. But yeah, I mean, we kind of waffled a bit on what we should make these as defaults, and we're never going to be able to choose a number that works for everyone, but we found 35 rays cast each frame to be a pretty good starting point in our testing. And so now the movement threshold applies mostly just to the emitters. So when a sound emitter moves past 25 centimeters in this particular case, that's going to trigger what we call path validation, which is where we compute the path from the listener to the emitter. And it doesn't need to refresh if the emitter doesn't move. The path validation also applies to the listener. So if the listener moves, it will trigger the path validation, but it no longer applies to raycasting. Getting a little bit into technical details here, but you can kind of think of the movement threshold as like how, what's the resolution of the path calculation algorithm.
Perfect part of the live stream to go deep. So thank you for adding to the live stream with these advanced settings.
Yeah.
It's good stuff.
So actually one other thing we changed in 23.1 is the way that diffraction works when you exceed the maximum diffraction order. So previously, if you had, so we have it set to 4 right now in Unreal here, and that means you can have a sound that diffracts over 4 edges, and then if there's another obstacle in the way, meaning that you would need a 5th or 6th edge to reach the listener, then previously what would happen is that sound would just cut out, and that is almost never desirable, and that kind of forced you to set a diffraction order that was like sort of high enough that you could be sure that never happened. And now what we do is we just kind of ignore all geometry past that that desired edge, and the paths actually start from the listener, so you can actually set the diffraction order to be fairly low. Even 1 or 2 can work in a lot of situations, and you're still going to get importantly, you're going to get the correct direction. The sound's going to come from around the corner or around an obstacle, and if the geometry behind that corner is sort of detailed enough that you can't calculate the entirety of the path, then it's just going to sort of cut through, and you're going to slightly underestimate the total distance and the total diffraction amount to the emitter. But this doing this allows you to save CPU by reducing diffraction order and just not have to worry about sounds cutting out. In terms of new stuff, that's I think that's the main gist of it.
Yeah.
Love it. Cool. All right, well, we're wrapping up over here. Feel free to drop any last questions into the chat. Happy to address them if we're able to. Otherwise, wow, what a incredible overview of all of the spatial audio acoustics features that we've been working on. I've been having, heart palpitations over here as I've struggled to keep Tali in the scene as technology has gone in and out of working correctly. So thanks for bearing with me as I smash those buttons trying to keep things working over here. As you see, I'm not able to resurrect her to the screen at the moment. Tali, I do see you. Your contribution has been invaluable. Thank you so much for driving the demonstration today. Great to have your hands and experience on the technology. And meanwhile, Nate, thank you for bringing some incredible insight on the depth of changes that have gone into the
Yeah, it was
new
fun.
features. Yeah, cool.
Thanks for hosting, Damien.
Thank you. Yes. Okay, well, it seems like the only way I can get you back is to go wide in one window. I don't.
I can stop sharing.
Oh, yeah, try that.
Okay, how do I do that?
But
Stop sharing.
I did find a way to bring you both back in. We're just doing this live because
Nice.
it's way more fun with friends, and I'm so glad that you were able to bring all of your experience to the live stream today. Thanks so much. I hear we're sliding into the end of the year over here. Exciting plans. Hopefully you have them out there in the community to dive into spatial audio. Keep us posted. Let us know how it goes. And wishing you a happy new year in advance.
Yeah. Happy New Year, everyone.
Yay.
All right.
Thank you.
Excellent work, team. See you on the other side, and stay wise. Until next time.